The purpose of reservoir storage is to supply water. To ensure storage safety and normal water supply, reservoirs should be equipped with drainage and desilting facilities. Since its completion in 1964, Sherman Reservoir has undergone several upgrades and renovations. Its flood and sand discharge capacities have been continuously strengthened. Today, Sherman can safely release the largest expected floods in its catchment area and effectively overcome mud and sand buildup that could adversely affect its operations. Sherman Reservoir has the most complex and most complete reservoir drainage and desilting system in Taiwan. It has four main facilities, which are, in the order of time of completion, spillway, drainage tunnel, desilting tunnel, and anti-silting tunnel. These facilities and how they work will be outlined next. The spillway of Sherman Reservoir, completed in 1963, was the most important anti-flood safety facility completed the earliest. This spillway controls the flow with 6 tainter gates that open to a same degree synchronously. Once they open, the water flows down the chute and jumps over a ramp to fall into afterbay. The spillway discharges at a minimum flow of 600 cubic meters per second, and the degree of opening of the gates increases as the flow gets larger. When the gates are fully opened, the water flow can reach as much as 11,400 cubic meters per second, among the largest in Taiwan. With so great draining capacity, the spillway of Sherman Reservoir can literally allow any flood from upstream to pass safely without causing overflow on the dam. This spillway can thus be called the best guardian for Sherman Reservoir. The drainage tunnels are the second largest drainage facility of the Sherman Reservoir. They were completed in 1983 with the purpose of assuming a part of the responsibility for flood in catchment, lessening the burden to the spillway. The inlet port of the drainage tunnel is located about 600 meters of the right bank upstream to the spillway. Like the spillway, it also discharges water into afterbay. There are 2 drainage tunnels, each of which starts working with a 200 cubic meter per second flow. Normally, either one tunnel is operated, but when the total flow exceeds 400 cubic meters per second, both tunnels may be active at the same time. Each tunnel has a maximum draining capacity of 1,200 cubic meters per second. Both of them total a 2,400 cubic meter per second flow. With the drainage tunnels, the Sherman Reservoir has a total draining capacity increased to 13,800 cubic meters per second, meaning a significant boost to the safety of the reservoir storage. The desilting tunnel of Sherman Reservoir was completed in 2012. It was modified from a power generation penstock in the wake of Typhoon Air in 2004 as an additional bottom hydraulic desilting facility 50 years after the completion of Sherman Reservoir. As its name suggests, a desilting tunnel is intended for desilting, while to be more specific, it is for removing the high concentration and fine particle mud current at the bottom of the reservoir, a density current. The flow in the desilting tunnel when fully opened is 300 cubic meters per second, which has only limited boost to the draining capacity of the reservoir. But that is highly efficient in removing the density current that flow very slow at the bottom of the reservoir. The Amuping Desilting Tunnel of Sherman Reservoir is the latest facility member of the reservoir. The Amuping Desilting Tunnel is about 4 kilometers long, having an inlet port located in Amuping, in midstream of the reservoir area. A sluicing basin is provided between the outlet port of the tunnel and Dahan River. The operation of Amuping Desilting Tunnel includes desilting, sluicing, and drainage. In normal time, the tunnel serves as a passageway for transporting sludge for desilting vessels, and at time of typhoon or flood, the inlet gate opens and to channel the flood water to sluice, flushing the fine particle sand deposited in sluicing basin out into Dahan River and finally into the sea. Designed with a flow at 600 cubic meters per second, the Amuping Desilting Tunnel works to desilt as well as helps drain the flood. Combining mechanical sludge removal and hydraulic desilting makes the desilting tunnel a composite desilting facility, which is one-of-a-kind innovation in desilting in the field of water resources. The sluicing operation of Sherman Reservoir during typhoons and floods is divided in 3 stages according to the contextual development, which are regulating sluicing, flood drainage, and desilting. At each stage, different draining facilities and desilting facilities are activated, as actually required. Regulating sluicing aims to lower water level early to bring about subsequent effect of flood detention and reduction. Flood drainage is operated in the principle of maintaining balance between inflow and outflow of the reservoir to avoid forming man-made floods. Desilting is intended for eliminating density current and restoring water level to return to storage. Due to difference in requirements by the context, the restrictive conditions to the operation of each facility differs. How to operate with varied combinations of spillway, drainage tunnel, desilting tunnel, and anti-silting tunnel safely and effectively poses tremendous challenge to the reservoir administration during typhoons and floods.